if you're comparing those two methods, string.length method would be faster. So it'll print something like this. So pass in 5 will print 1 through 5 like this. And if you print 6, it'll print 1 through 6 and so on. So you get the idea. So the next one would be, let's do right numbers, and you pass in 1, and that should just print, get the concept. So if you put 100, it'll print 1 through 100. So this is pretty easy to do with the for loop. The only reason I want to do with recursion to get you guys used to writing recursion function, and this one is a good one to get started. So you guys will help me write this when I get started. So I'm going to write the function header and public static. We're not actually returning anything. We're gonna be printing to the screen, so it's gonna be a void, and I called it right number. And that, what's the parameter? I'll just call that n. And where would we get started? What's the base case? What's the recursive? What's the base case and what's the recursive case? So we know we need some kind of base case if, and then we need some kind of recursive case. That would be else, or base. Either this could be recursive and this could be base case. It doesn't matter. So base case is if number is equals to 1. So if they're passing 1, we just print 1. So yeah, we can use that as a base case, and we can actually look at the sequence, right? We start at 5, and we're gonna have to print backwards. So where do we end up? We end up at 1. So we can use that as a base case. So n equals 1. And what happens if that's you're using number? I'll just change that. So what should happen if this is the case? N equals 1. The recursive could be 1 plus right number n minus 1. We'll get to the recursive case in a minute, Jennifer. What would be the base case? Like what goes in line 13? So we found the base case, which is n equals to 1. That makes sense because if it's 1, we just print solution. So print, would it be print ln or print? All right, and I'm just gonna print. All right, so now the recursive case you said should be something like this. And recursive case you said system.out.print, and you want it to 1 plus number. As I'm getting it, if I do something like that, that was the solution, right? Maybe I did 1. So what's there? Let's look at the error. So this, remember, this function is not returning anything. It's a void. So that's why we're getting this error, because you're trying to do plus with a void because it's not going to return anything. Exactly. Yeah. So it's void. So when you do something like this, if this had a return value, I think that might have worked, but it doesn't have a return value. I remember my ID asked me to put return null in a void method one. How can we fix that? So let's look at the logic. So what do we need to do? So we have a number. We start at 5 right here, but we have to print backwards. We can't just print 5, 4, 3, 2, 1, right? So we need to start at 1 and then print everything afterwards. So remember, if you need to print everything afterwards, I think we kind of went over that last week. Where do we need to put it? So let's out, and I'm going to move this. So this is the right solution. It looks like it because we need to decrement number by 1. It is decrementing by 1 somehow, or increasing by 1. But we just need to print out where do we need to print it. So if you print the n right here, so I just print the number. So I'm going to do followed by, so when we print the number, we'll be able to see. So what's going to happen here? So 5 comes in here, it checks this logic, the base case, stops the recursion, and this is the recursion trying to join in. All right, so now 5 comes in here, 5, we compare it to 1, that does not equal to 1. We go into else case, and in else, we print the 1. We print the number, which is number 5. So we print 5, and then we have a space. What happens after we go in the recursive case? 5 goes in here, 5 minus 1. So now new number is 4. 4 comes in here. We do the same thing and we print 4. But that's not what we want, right? We want to start at 1 and go to 5. Right now we're starting at 5 and going backward. How can we fix that? So we need to print below the recursive case. So if you print below it, so why do we have this? I mean, Jennifer or anybody else, how did you guys come up with this? Just so everybody's clear. Before we run it and see what's going on, but how did you guys come up with this? We need to see a pattern in the solution or the output or whatever you're trying to do. So the pattern here is it's number, we start at 5 and we're decrementing by 1. So that's how we get the solution. You need to change the number, calling the function. Yeah, so we need to change the function, the number decremented or incremented somehow. And the pattern we can notice here is we're decrementing. So we're going 5 through 1. Doesn't matter if we're going from 5 to 1 this way or this way. We do know we need to do something with this number, and that is -1 every time we call the recursive function. That's how we got this. Now we just need to figure out where this print statement goes. We tried putting it up here, and that prints it backwards. Now we tried putting it down here, and let's see if that's going to work. So I'm going to run it and see what happens. But before we run it, let's go to, I'm going to use my draw function. So now n is equals to 5. So remember in the final, we don't have midterm anymore. So in the final, you may be asked to go over or read a recursive function. So get in the habit of writing everything down to trace it. So right now n is 5, n equals 1, does not equals to 1, then it goes to else, and then we call the recursion. We call here is n equals to 4. Then at this level, we still have the print statement, right? We haven't executed it. We just call the recursion, execute the recursion first. And then here we have the print statement as well. And then we go into recursion again. So if n is equals to 4, 4 comes in here. We check equals to 1, does not. We go into recursive case and we go into recursion again. So then we have n is equals to 3, and we still have the print statement. I'm just writing P so we don't forget we have a print statement still to execute. Remember, it does not execute the print statement. It takes care of the recursion first and then everything after. Now 3 comes in here. 3 does not equal to 1. We go to else case, and the else case is recursion again. 3 minus 1 is 2, so n is equals to 2. Then we still have a print statement to execute, but we need to take care of the recursion first. And then 2 comes in here, and 2 minus 1, 1 comes in here. So this would be n equals to 1. 1 equals 1. Yes, we print 1. Now we print 1 to this side. Then in here, we don't have any print statement. We don't have print statement because we never got to the recursive case. We got to the base, and the base case actually printed. So we have the one right here. So this is the output. All right, so now we backtrack. Now we go back up, and when n was 2, we executed this statement. Now we have this statement execute. Now we print the value of n. At this level, the value of n was 2. We print that. Now all the lines of code have been executed. Then we go one level up and we have a print statement to execute. And then we print number plus space. Number at that point was 3. We print that. Same thing, we go backwards and we go back up. We have one line to execute. Remember, we left at this line, right? We didn't execute anything below that. So if you had more lines to execute, we would just execute it one by one. But we only have one line, and that one line is printing the number. And in this case, at that level, the n number was, then we go back up again, and we did this, we did this, we did this. Now we have this print statement to execute. At this level, the number was 5, we print 5. So one thing that this 1 and 2 does not have any space in it. Does not have any space because when we printed 1, there's no space after it. And when we printed 2, there's no space before it. It only has a space afterwards. So it has a space here, space here, space here, and space here. There's no space in 1 and 2. So if you run it, so we can't really run it. So there's no space here, but there's space right there. Okay, able to see. How can we fix that? We should be just adding a comma, not a space and a comma. So which line should we go and fix it? So I'm gonna clear the drawings. So where can we fix that? Line 17 right here. So we have a space afterwards. What should we do? Swap the number and space in the line 17. All right. So it's afterwards right now. We just need to put it before. That's the solution. Let's see if that's gonna work. So something like this. So yeah, that worked. We print 1, and then afterwards we have a comma, and then 2, then comma, 3, comma, 4, comma, 5. So every time you write a recursive function, 2 things you need to figure out. What's the pattern for the recursive case, which in this case, the number is decreasing by 1, and then the base case, where would it stop? Where do you think would it stop? And in this case, I kind of gave you a hint. I wrote down 1 and would give you 1. So that would be the base case. When it's 1, you just print out 1. So in this case, you actually don't have to print out 1. You could also just print out the number, because when it gets here, it is 1. On homework or anywhere else, you may get questions like, if it's negative number, throw an exception. So if it's a negative number, if number is negative, so right. How can we add that in there? Where would we add it and how would we add it? throw a new illegal exception, no negative numbers. Where would be added? If number is would be additional base case, yes. Excuse me. So it would be like a special case, right? So it's not required to run this method. Doesn't actually stops the recursion, but it's actually just kind of like a special case. So it'll be if a number is less than one, and so the first thing we're gonna check is if it's valid, right? So if the number is not valid, we just throw an exception. So it should be the first case, because if it's not going to be one. The first time we check is if it's negative, we don't even do anything. So that should be the first one, and then we do else. If that's the case, we don't even need to check anything. All right. So in here, I'm just going to copy what Raymond said. Throw new exception. I think I've talked about this before. Once you go to industry, this is actually not a good thing in your code. Every time you throw an exception, that's nobody. I've been working for years and years, but I haven't never wrote a line like this in industry. You always have to catch it, and you have to do something with it. Otherwise, the program breaks. Once the program breaks, you can't really do anything. Because once you give it to your user or your client, and the program breaks, that's it. I mean, you either get fired or they're gonna catch this in testing, and they're gonna send it right back to you. Like, why are you throwing an exception? You should know what that exception does, and you should be able to catch it and save the program. Don't ever crash it. Right now, when you throw an exception, the program kind of crashes. Fast and -5, and the program crash, and it just throws an exception. Yeah. So you should do a try and catch block, but for this, focus is recursion method, not throwing exception. I think we covered exceptions in when we were doing file a little bit, how to do a try and catch block. But for right now, this is okay. Even if you write this in your homework, I'm not going to take off any points, but I'm just letting you know in real world could be number less than or number. Yeah, so we can add that in there as well. Or number equals null, and that does not work. This actually doesn't work because in Java, null is always defined as 0. So as soon as something is created like this, you won't be able to pass a null to it. It's either 0 or it's defined somehow. So null is used for objects. So the string object, you can use null, or any object that you create is null. So string is an object class. That's why it has built-in function. It's a topic for a different time. This, I'm going to move this function down. Let's write one more. Let's write digit match would accept two parameters. Digit match will match two parameters, x and y, and it would compare their digits and would return how many digits the same. So let's say the x equals 2 equals to something like this, y equals to. So now it's going to compare 9 to 9, 8 to 8, 7 to 7, 5 to 4, every single value according to this. And then it's going to return, in this case, it's going to return 3 because 3 digits are the same. We had x equals 2 and 5 and y equals 2 135, what would be the return value here? 2. So 1 and 5 are the same. This would return. What this function needs to do, so I'm going to write the header, and we'll go to do this together. Static, and I'm thinking it would be an easier solution to keep the same amount of digits throughout the entire calculation, and subtraction and biggest number from the smallest one, then count to 0. So yeah, we can do it either way, but it should here. Let's stick with this one. So the length of the integer is the same, and then we'll worry about it. So public static. Is there a return value? I mean, is there a return type or is it void? Yes, the return value is or the return type is int because we return a number. We don't actually print it out. We return it and int, and we call that math, and it takes two parameters, so they're both int. What would be the base case and what would be the recursive? And I think once we figure out what the recursive case is, then the base case will become easier in this one. So what do you guys think will be the recursive case? So we do know we need if statements. So I'm going to go to every time I write recursive function, I have this in place. I know one of them will be recursive, one of them will be a base case. I just don't know which one is which at this point. Just to get me started, I write this down, and then I can figure out what's the logic behind it. So now, if you have a number like this, or just start with something small like this, how did you extract the last digit? How do we extract the last digit and compare it? I think you guys worked on it in the last class, maybe not that much, but two questions here. So how can we, if we have a value of x equals 2, 1, 4, 5, use modulus? Yes. So what would happen if you have a modulus? So let me take it out. So if we have 145 and we need to extract this right here, right? What would be the value of modulus? So we're trying to do modulus, modulus takes the remainder, and that should work every single time, like for every number. So it doesn't matter if it's 145, it could just be 5. Can you guys think of a number that would work? Modulus, you do modulus 10 and then recursive on that. Yeah. So modulus 10, so we have 10. And how many times 10 goes into 145? 14 times. And that's 140. And the remainder is 5. So if you do 10, the number, or whatever the number is, 145 modulus 10, we get 5. So we extract the last. So it doesn't matter if it's a big number or small number, we can do the same thing with number 5. So we have 5, and we do modulus 10. How many times 10 goes into 5? 0 times. 10 times 0 is 0, and we still get. And now, so we got this. We need to do modulus 10 to extract the last one. We can compare the last value by doing modulus. But how can we, what's the pattern here, right? So before the pattern was n minus 1, every time the n or the number was decrementing by 1. But in here, we need to compare this one, then this one, then this one, and then this. So once we compare this, and if we're doing modulus 10 every single time, we need to get rid of these two numbers. How can we get rid of those two? Number divided by 10. So if you have a number, 145, we have 145, and this one we're not doing modulus, we actually doing divided by 10. How many times 10 goes into 14? 145, 14 times, and 5, and then, so 140, and then 5 is remainder, but if we do division, we take this number right here, right? So that means we got rid of 5, we got 14. The same thing if you have a one-digit number, if we need to get rid of it and see if anything below that, we can divide by 10, and then the end result is 0. So if we need to get rid of the last one, compare the last one and get rid of the last, right? So we just need to figure out how can we write this. And so we need to do modulus to compare two last ones, and then we need to get rid of last ones by doing divide by 10. Do x length have a function? No. So integer, integer, this right here, it's not actually not a class, it's primitive data type. So they don't have any built-in functions. Like it's not an object. Right? If it was a string, string has built-in functions because it's an there or integer up. Yeah. So this, if you have integer objects like the whole word integer, then that becomes an object class. And then we have something like that. So you want a digit count variable at the beginning to keep track of the number of matched digits. Where would be added, Jennifer? What line? I mean, number of a lot of comments. Let me read through it. That you would return at the end before the if statement. So before the if statement, you have a variable called digit count. And what should we set it to 0 to start? So how I'm kind of confused. What are you asking? So you have x equals 123 and y equals 2, 1, 2. So in this case, nothing would be matching, right? Because we start from the back. So in this case, we'll compare 2 to 3 and 1 to 2. If you want to compare something, right now our focus is they're the same length. Is that what you were asking earlier? Yeah, so the length has to be the same. All right, so we have digit count starts at 0, and what else? Digit count is 0. So did anybody figure out what the base case is? When would we stop it? So would it be this if right here? So y equals x equals y. We can try that base case. So we have x, we're going the other way right now. So we have if statement when we have x modulus 10 equals y modulus 10. If that's the case, we need to increment digit count like this. What else? Oh, you have a separate if statement in the recursive. Let's do something like this then. So we have if, so we still don't have the base case or the else case. So is that what you're saying something? So what would be the base case if there's only one digit? So Hal had a base case if they're both equals, x equals y. and that would be the base case. Would that work? You say when the number is 0, why would that be, Raymond? So we have, so you do x, 10x equals 0, because you've gone through all the digits. So this case right here, that's what I wrote on right here. This, if you have one digit, right, we still need to compare it. We still need to compare the last digit, right? We know we're at the end when it's 0. There's no other value. So how can we get to that? And so we only get to this, that means we don't have anything else to, and we just do if x equals 0 and y equals, right? Remember right now, we're doing the same length. So if they're both 0, that means we've gone through the whole length of the integer. If that's the case, that means that's the end, and we should return something here. What should we return? Because doesn't everybody understand the base case? So you have base case when each of those digits is 0. So when there's one digit past 10, we still need to compare it. And the way we compare it is, so Jennifer is on the right track. We compared the digit by doing a modulus, and the base case would be something like this. So if you do just return 0 or something like that, we'll come back to this. What should we return? That would be the base case, and we can use this as a return. So we do if that's the case, we increment the count. What else should we be checking, or should we be checking for anything else? Would negative numbers be concerned in this scenario? So right now, yeah, there's a lot of assumptions that we're making. One of the assumptions is it's not negative, and the other assumption is the length of both of the integers. The two assumptions are length of numbers is same, and they are non. So what is the recursive case? What should be the recursive case? So let's see what we have so far. We have x value, y value coming in. Now we need check if they're both equal to 0, then we return 0. Would that be the case? So the 0 is passed in. Are we returning 0? X is 0, y is. That's what the user passed. It's not negative values. They're 0. They're allowed. That comes in. Does the base case make sense? What should it be returning? This should be 1, because the only thing here we're comparing is two numbers, right? So if x equals 0, which in this case it is, y equals 0, in this case it is, that means one of those digits, whatever is coming in, they're equal to the y value. So now at this point we should be returning. Now then we have, let's say we have 22, and so sorry about my handwriting, and 32. Let's do 32. So those two values are coming in. Then we have, they're not equal to 0, so we go into recursive case. So that would mean we would return 1 for multi-digit numbers, right? Well, let's go ahead and check it out and see what it's actually going to return. We'll trace it and see what's going on. So the function is not finished yet, because we don't have a recursive. I'm just trying to test it out. We have 22 and 32 coming in, and then we don't go in here because that's not true. We go into else case, and the else we do mod 10, which is this number, and y mod 10, which is this number. If they're equals, increment the count. Great. Count is equals to 1 now. What happens next? The next step should be we compare these two. Right now we're comparing the last one, then we should move on to the one before that. How would we write it? Remember, to get rid of the last value, we figured we have to divide by 10, and that gets rid of the last value. So let's do, I'm just going to copy what you wrote. Now we have matched digits, and x divided by 10, that gets rid of the last value, and y divided by 10 gets rid of the last value for y. Right now, I'm getting an error right here because I don't have a return statement. Should I be returning this, or what should I be returning? So we need to return something, right? And if we have a count here or something, a return value here, we need to carry that up. The only way to carry that up would be to return the recursive case. So we do something like this. Now we're still missing something, but let's go through it and see what's going to happen. So now go back to, we're tracing 22 and 32. We compared it. That's the case. Increment digit count to 1. That's great. Now we call recursive case, which is match digit, and then we can pass in 2 and 3. Pass in 2 and 3. What happens if you go in here? They're not equal to 0. We don't do anything. We go into else, and we compare this. So first thing happens is we reset that back to 0 when we call the recursion. So digit count is set to 0. Then we go into recursive case. That's not true. We don't go inside the if statement. Then we call recursion again, and in this case we pass in 0, then 0 passes in, then this is true, and this is true, we return 1, we carry that return 1, 1, 1, and in this case 1 is the answer, so we get 1. So now let's do x is equals to 3 to y equals to 3, 3. Now we have digit match, then we go in, we have digit count, so I'm going to call that DC. I'll just call that DC. Digit count equals 2, right? Then we go in here, that's not true. We go into recursive case, and the recursive case we compare this value with this. That is true. We increment digit count to 1, and then we have a recursive case, which is just match digit. So recursive case, we have x equals 2, 3, 2, and y equals to 3. Everybody agrees? We go to the recursive case. Now we go in here. We reset digit count. Then we go into base case. That's not true. Recursive case, this value with this one. That's not the case where we don't increment this. Then we go into the recursive case again. Not the recursive case, but we call the recursion right here, with x equals 2, y equals 2. Now we call recursion with these values. We set the digit count to 0, and then is this true? That's not true. We go in and check the value x mod 10, which is 3, y mod 10, which is 3. We compare them, we increment digit count to 1. We call recursion again, and in this case to 0, and y we call recursion again, and we set the digit count to 0, and then we go in, and the base case is when they're both equal to 0. They both equal to 0, we return 1. 1 gets returned, value 1. Do we have anything else to execute here? When I run this, it doesn't return the correct values. So we're still missing something. So I'm trying to show you what are we missing, right? So 1 gets returned here at this line right here. So whatever this function returns gets passed to the level up. So this 1 gets returned again, 1 gets returned again, and 1 gets returned again. So every time we do this, we should be getting. We're not actually keeping track of digit count. We're not passing that up on one level. We're not adding this to our count. We're just keeping this return 1, and that goes all the way to the top, and this function returns 1 every single time. So this digit count right now is actually not doing anything. We're not carrying that count up on the level. So if you run this, well, let's actually run it and show you. Let's do match digits, and we pass in 3, 2, 3, and then we have 3 system dot out, print whatever the return value is. So that's why I put that in there. So if you run it, that should, according to this, according to our tracing, we get. So now let's try a different number. We add 3 here, and we add 3 here again, and run it. We still get. So we're incrementing the count, but we're just not carrying that up top. So Jennifer had a solution. We just added to the return value. So we do digit count plus something like this. Now every single time, if we have an increment in the count, we carry that up on the level. So the 1 would be passed in here, and whatever the digit count is, we add it. So if the digit count was 1 at this level, we do 1 plus whatever the return value is. So we pass in 2. And digit count was 0, we don't pass anything. We just do 0 plus 2 and pass that up. So in this case, it will be 2 plus 1, and we pass. So 1 is always, the count is always higher by 1. Okay, we don't actually check if the base case where there is only 1 digit, if the digit matches. Let's get back to this, Jennifer, in a minute. So let's test it out and see if we have something we can work. Let's run it and see if we get. So right now we're passing in 3, 3, 2, 3. So this should be returning 3. This actually returns. So where did we go wrong? The count is always higher by 1. We don't actually check a base case where there is only 1 digit. If the digit matches, you run this code, the 2 numbers that don't match at all, then it still returns 1 when it should be 0. So the base case, you said we got it wrong. This should be 0. Is that it? So run it. So we get this works. Let me take out this 3. and this 3. So then in this case, it should return true 2. Let's see if it returns. It does. So this is working. But right now, we don't have a case for 0. If we pass in 0, then it returns 0. That doesn't work. Is there a way we can fix that? So right now, we don't have a case where we pass in x equals to 0 and y equals to 0. We don't have a case for this. If we pass that in, we return 0. But in reality, they are equals, so we should be returning 1. We kind of passed the break. We'd add a separate base case for it, but what would that base case be, right? So that statement would look exactly like that. If x